3-eye atlas. For decades, Pluto has been a world shrouded in mystery, the lonely outpost of our solar system, frozen, forgotten, and forever at the edge of sunlight. When NASA's New Horizons spacecraft flew past it in 2015, the world gasped. For the first time, we saw its glaciers, mountains, and shimmering atmosphere, but something in that data didn't make sense. Something NASA quietly left unsolved. Pluto's atmosphere was far too cold. Models predicted a temperature of around degrees C, but the real measurements were over 30 degrees colder. That's not a small error, that's a cosmic anomaly. Something or someone was cooling Pluto in a way science couldn't explain. For nearly a decade, the mystery went unanswered until now. Because the James Webb Space Telescope, the most powerful eye humanity has ever placed in space, has finally uncovered what's really happening on Pluto. And the truth is far more shocking than anyone imagined. Back in 2015, when New Horizons sent back its breathtaking images, scientists expected a barren world. Instead, they found towering mountains made of water ice and smooth plains of frozen nitrogen stretching for hundreds of kilometers. But above this alien landscape hung something unexpected, a thin bluish haze wrapping the planet like silk. It wasn't dense, but it reached nearly 300 km high, far taller than anyone thought possible for such a small world. It shimmered under sunlight, layering itself into delicate glowing bands. But the most baffling part was not its beauty, it was its temperature. The atmosphere was freezing far beyond what nitrogen and methane alone could account for. For years, scientists ran models, recalibrated sensors, and rechecked data from every angle. But the math refused to work. The energy didn't add up. Something invisible was stealing heat from Pluto's skies, and no one knew what it was. Then in 2017, a planetary scientist named Zhang from the University of California, Santa Cruz, proposed something revolutionary and to many ridiculous. What if Pluto's haze wasn't just a passive layer of dust and ice? What if it was alive in a chemical sense, actively regulating the planet's climate? According to Zhang, those tiny solid particles floating in the upper atmosphere could absorb ultraviolet light from the distant sun and re-emit it not as visible light, but as mid-infrared radiation heat. But instead of warming Pluto, that process was cooling it, radiating energy away far more efficiently than gases could. In short, Pluto's haze might be functioning like a massive thermal shield. Most scientists dismissed it. The idea that particles could dominate atmospheric temperature control went against everything we knew about planetary physics. But Zhang's theory made one bold prediction. If true, Pluto's haze would emit a distinct mid-infrared glow, a signal so faint it could only be detected by one instrument in existence, the James Webb Space Telescope's Mid-Infrared Instrument, or MIRI. In May 2023, it finally happened. An international team led by Tanguy Bertrand pointed the James Webb Telescope at Pluto and its moon Charon. For the first time in history, Webb's precision allowed scientists to separate the faint heat signatures of the two worlds, something no previous telescope could do. Using MIRI, they scanned Pluto across multiple infrared wavelengths. 15, 18, 21, and 25 microns. The data was staggering. Pluto's infrared glow was stronger than expected, far too strong to come from its frozen surface alone. Something above it was radiating extra heat into space. When the team subtracted Charon's contribution and isolated Pluto's atmosphere, the results were undeniable. The spectral lines matched exactly what Zhang's theory predicted 6 years earlier. The haze wasn't just scattering sunlight, it was glowing, radiating infrared heat like a cosmic exhale. NASA had finally found the missing energy. The haze was not a byproduct, it was the cause. This discovery rewrote everything. For decades, planetary scientists believed that gases controlled climate, from carbon dioxide warming Venus to methane shaping Titan. But on Pluto, solid particles, microscopic tar-like compounds called tholins, were running the show. These tholins form when ultraviolet light hits methane, triggering a cascade of reactions that create complex hydrocarbons. As they drift downward, they create layer upon layer of haze that glows in infrared, cooling the atmosphere from above. The entire planet functions like a massive chemical engine, its haze forming, radiating, and collapsing with each orbit. Even more astonishing, Webb's data revealed that methane from Pluto's atmosphere is leaking into space and falling onto Charon, where sunlight transforms it into the reddish organic compounds seen on the moon's poles. In other words, Pluto is literally painting its moon. But that's not the most shocking part. Webb's readings also hint at something deeper, evidence that haze-driven cooling might not be unique to Pluto. It might be happening across the solar system and beyond. After Webb confirmed that Pluto's haze was actively cooling its atmosphere, scientists began wondering what else might share this strange phenomenon. The first suspect was Titan, Saturn's largest moon, a world already famous for its thick orange haze and methane-rich skies. Webb turned its gaze toward Titan's limb, and what it found was eerily familiar. The same infrared wavelengths seen in Pluto's glow appeared again, but stronger. Titan too seemed to be radiating away its energy in mid-infrared waves, almost as if its atmosphere was alive, breathing heat out into space. The spectral pattern was so similar that researchers began calling Titan and Pluto mirror worlds, both frozen, both wrapped in haze, and both governed by a chemistry that seemed less planetary and more organic. Even Neptune's moon Triton, once thought to be geologically dead, began showing faint atmospheric heat signatures in Webb's data, hinting that its own nitrogen haze might operate under the same principle. The realization was staggering. These distant icy bodies weren't silent, they were active. Their skies were talking to each other across the cold reaches of space, following the same invisible code that seemed to dictate how light, heat, and life interact at the edge of the sun's reach. The compounds driving this cosmic cooling tholins turned out to be far more complex than anyone imagined. Under Webb spectroscopy, the chemical signatures revealed dozens of hydrocarbon chains, some containing nitrogen and oxygen bonds, the same foundational elements found in amino acids. On Earth, similar reactions occur in the upper atmosphere when sunlight interacts with methane, the same process that may have sparked the first steps of life billions of years ago. In other words, Pluto's haze wasn't just cooling its skies, it was cooking chemistry. Dr. Bertrand described it as prebiotic photochemistry on a planetary scale, but here's where it gets strange. When Webb analyzed how these molecules formed and reformed, it detected a rhythmic cycle, a repeating pattern in how tholins absorb and emit infrared light. The interval between emissions matched Pluto's 6.4-day rotation period almost perfectly. The implication, the haze wasn't a random chemical fog. It was responding to the planet's daylight rhythm, as if synchronized to the pulse of sunlight itself. The boundary between physics, chemistry, and something more began to blur. As Webb's data continued to pour in, researchers started comparing Pluto's cooling mechanism to other worlds outside our solar system. In exoplanetary systems orbiting dim red dwarfs, several worlds, including K218b and TOI 700d, showed faint mid-infrared dips identical to Pluto's spectral haze lines. At first, it seemed impossible. These planets were far larger and warmer than Pluto, yet their atmospheres behaved the same way, glowing faintly, radiating away excess energy, stabilizing themselves. That stability could mean one thing: habitability. Instead of chaotic, storm-torn worlds, these planets might sustain mild, temperate climates beneath their hazy skies, shielded from solar radiation by the same tholin chemistry that cools Pluto. The discovery shattered the traditional definition of what makes a world livable. Life might not need oceans or sunlight. It might begin in the dark, within a haze that protects and regulates, a self-sustaining chemical feedback system born in the cold. For the first time, scientists began to suspect that Pluto might not be an anomaly. It might be a prototype. When Webb's findings reached NASA headquarters, several internal reports were quietly pulled from public access. One of them, labeled Atmospheric Anomalies, Pluto and Triton Comparative Study, contained references to non-thermal infrared emissions inconsistent with radiative equilibrium models. In simple terms, Pluto was breaking the rules. The data suggested that the haze was absorbing energy from unknown sources, not just the sun.